Good morning to everyone. I'm expecting we'll probably have a couple more pop in. Let me go ahead and share my screen though, and we can jump in and get started on this. I'd like to just spend a minute to chat with you. I'm looking at who's in, yep, everyone who is here. I would expect them to be here because I keep track of the replets to see who has solved the replets, and I can see that just about everyone who is in this list has in fact completed all of the replets all the way to where we are. So I'd like to ask, let me think of who is here. David, you said you had done some programming before. Sean, had you done programming? Sean Thompson, can you hear me?
Yeah. No, not really.
You had not. Cool. Are you needing help on any of the replets? Is David helping you, or are you getting them all done yourself?
Yeah, my brother helps me.
Okay, cool. I'm trying to think of who else did I see. I think Chloe and Charles, you both have done programming before?
Yes, sir.
Yes, I have.
Okay. So is everything till now kind of easy, or is there anything you have not seen that this is the first time you're covering it?
Just the language is different.
Okay.
And same for me.
And y'all had both studied which language?
Java.
I also studied Java.
Okay, very good. And who else? I think it was Charles. I believe you had studied before. And Coulson, is this your first time studying programming?
Yes.
Yes. Okay, well, fantastic. And is anyone helping you?
I sometimes take help from my dad.
Gotcha. And he knows a variety of languages?
I think so, but he knows Python.
Okay, great. Well, I hope that we can get to something that is, or let me ask you, are any of the replets challenging this week? This is for anyone to speak up.
I think it was just like trying to think of the problem rather than actually like do the actual code.
Absolutely. And that should be the case. You know, we tell students that this is problem solving, that Python is simply a tool in our problem solving tool set, toolbox, so that the real problem should be, or the real issue at discussion should be problem solving. And so yeah, if we're getting to problems where you just have to sit there and think, and maybe 10 minutes later you finally get, you know, a spark and an aha moment, and then you can go do the code, which is probably less than, you know, 10 lines, maybe less than 5-6 lines. That's great. That's what we're looking for, because you can see that it's not really the code, it's really the thought process used in solving it. So cool. A couple of things. Let me go ahead and I'm going to come to Slack. Where should I put this? Programming assignment. I want to attach. Let's see, what all do I need to attach? Bear with me. 1 second. Let me hit stop share for just 1 moment. I want to make sure I get the correct files where they need to be. Programs 1 and 2, 2080. So I wanted to briefly talk to you about this second programming assignment, which I thought I had everything here, but apparently I'm wrong. Sample runs. Just bear with me 1 moment, please. Right-click. And 1 more, I'm just renaming 2 things. Okay, sorry about that. Share. So I'd like to upload, if you look at Slack, upload from my computer. program 2, and I'm going to upload first the PDF of program 2 for anyone who wants to work on this. These replets are small little problems, right? If you want to do something more meaningful, and I'd like your feedback of how you think these are as compared to any programs that you had to study when you did or what you had to solve when you did take Java. And here are the other 2 files. So what I have here, let me just show you. I think it's easiest. I have 3 files here in Slack. Okay. So the first is a PDF of the actual write-up and description of the programming assignment, and which I'll look at briefly. But the other 2 files are sample runs of the program. One is as a text file, and you probably, I don't know if it's going to open from within Slack, but it's just a text file. Okay. Here's sample runs of the program. It's not pretty, but the purpose of giving you the text file is so you can then come in here and highlight whatever portions you think that you want to just directly copy from here into your program as opposed to retyping. And it's easy to highlight from a text file. You can highlight the spaces and everything, as opposed to highlighting from a PDF. It's hard to highlight. It doesn't usually copy spaces and tabs very well. So here is the, so I'll do this from Slack instead. So if you go to Slack and you click on this file right here, pardon me, this file here is again the same sample runs of the program, but instead of as a text file, it's as a PDF. And the reason I make this as a PDF as well is just so you can see it color coded, so you can see what the user actually inputted. So basically, this is what's going to happen when you run your program. You print this menu, and we ask the user, do they want to practice addition, subtraction, multiplication, or division? And at this juncture, at this point in time, we're not confirming the accuracy of their input. So of course, if the user entered something other than a 1, a 2, a 3, or a 4, you would expect your program to crash or act incorrectly. And that's fine. We're not trying to take care of that issue right now. We're not there yet. And nor do I encourage you to try to flex and do that. That's later. Pardon me. So just assume that the user will enter correct values. So here, when they enter 1, what happens now is you get this menu. Well, this heading that prints with plus signs around it. And we ask the user, how many questions would you like? 3, 4, or 5? And this is a little bit repetitive, this programming assignment, and I made it like that. It is by design. There's a component of problem solving, which we do with replets. There's also a component of just sheer volume of wanting you to get some muscle memory on certain Pythonic and programming actions. And so there's a certain component of volume of code, as opposed to, as well as the volume, the difficulty. So here, we're going to start learning this week about looping. Okay, we're going to start learning today about loops. However, this programming assignment has nothing to do with loops. So anyone who wants to solve it, you should not use loops. This is not, again, using loops like flexing and it's like, oh, look at me, I can use loops. No, you actually made it so much easier on yourself. This program it will probably end up being, for anyone who wants to solve it, probably about 800 lines of code. Of which a lot of it is just copy pasting and then just changing values. You'll see, but it's a assignment of the purpose of volume by design to get just practice with more and more quantity of solving a larger problem. So here, when the user says they want to enter 3, or they want to answer 3 questions, and let's just here. Let me actually show you the multiplication is probably the easiest one. So here they choose multiplication practice. So they choose number 3. You print this heading with X's around it. How many questions would you like to answer? They say 3. So then we give them the following 3 questions. 9 times 2, let's say they put the wrong answer, they put 10. So you have to tell them that is not correct. The correct answer is 9 times 2 is 18. You ask them another question, that's not correct. The correct answer is 10 times 7 is 70. So here we asked them 3 different questions because they said 3. All 3 were incorrect, And we immediately print the correct answer if it is incorrect. And then you tell them you answered 0 out of 3 correct. So that means you had to have a counter. You had to keep track. So while you're asking them this set of 3 questions, you had to keep track how many were correct out of the 3. And then you have to just print a little bit of math here, the percentage correct in this case, which is 0. And also, this is what's going to take a little bit of thought. It says, here are the questions you missed. Practice them for next time. So it's one thing to, as soon as they miss the question, to immediately print the correct answer. That we've already done on one of our math practice, like probably version 3 or 4 from last week or the week before. But now, how are you, so it's one thing to, to print this here, that 9 times 2 equals 18, or the correct answer here, 10 times 7 is 70. That's one thing. But now, how do you do this all at the end, after you've given them their score and you somehow kept some type of variable with a value inside that kept track and it saved into it all of the full equations of what they had typed incorrectly, of their ones that they answered incorrectly? That's something for you to think about, of how you would possibly do that. And we have given you enough tools in your toolbox of how to solve that. You just need to brainstorm of what you would do. But for clarity, let me show you. I should have shown you this one first. Here's multiplication if they choose 5. They want to answer 5 questions. So they answered the first one correct. The next one they answered incorrect. This one they answered not correct. This one they answered correct and then correct. So they answered 3 out of 5 questions correct. So you had a counter. That's pretty easy. But again, this is not done in a loop. So this is just done where you're not doing it in a loop, because we haven't learned loops, okay? Those who know loops, many of you do, you're not using loops here, which makes it more challenging. If you use loops, it would be easier. But if you really want to solve this, don't use loops. This will be you'll get value from solving this without loops. Here, so they answer 5. They entered 5. You ask the 5 questions. You print how many correct, and you print your score. And then you print at the end below, here are the questions you missed. You should practice them next time. Okay, that's a little challenging to think of how you're going to do that. But each one of these are independent runs of your program, again, because this is not in a loop. Even the menu is not in a loop. So at that point, the program is finished. Okay, here was subtraction. And then here is the multiplication we showed you. What about division? So look, I want to point out one thing to you. And we have talked about random numbers, right? We've used random. We've talked about how you can make random numbers. We've used them for a variety of things, including the various math practices that we solved together. I think it's worth my opening that up very briefly. Close, file, open. Module 4. Yeah, so math practice version, math learning tool version 4. So this is one we've already seen and done in class in one of our sessions. So here, remember, we imported random. We made 2 random numbers, and we simply did what? This was the subtraction without, bear with me, I'm sorry, I'm just trying to look this over. So we did not worry about swapping here. Or I think I asked y'all to do that, but I didn't actually code it myself. Did y'all do one where we had to swap the 2 numbers to make sure that it could not possibly ever result in a negative number?
Yes.
Okay, good, thank you. So I probably just didn't code that. So here is one, for example, where we did this repeated subtraction. But if you notice, I did not even set it up as subtraction. Y'all each solved this. So this, of course, should have been a negative. This should have been a negative. This should have been a negative. What else? So I wanted to at least show one thing to you where, let me see if I can just run this very quickly. Do I have everything working correct? Let me see. 7 minus 9. So this takes, yeah, no, hit stop. So what do someone tell me, unmute your mic and tell me what I need to do to be able to swap these conditionally if, I don't want to tell you what the if statement is. I want to be able to swap the 2 numbers if the first number is strictly smaller than the second number. Tell me what I need to do for code. Swap num1 and num2 if num1 is smaller than num2. Someone quick. Quick. This is not what we're supposed to be doing right now.
If num1 is less than num2, then go to the next line, num1 comma num2 equals num2 comma num1.
Okay, that's how we need to swap them. So I need to get rid of this comment. Let's see if this works now. 6 minus 3, if I put 2, sorry, that's incorrect. Correct answer is this. Run it again. 4 minus 2 is 2. Fine. That's not the best enlightening. I need to put minus here. Let's try that again. 8 minus 6, 2. Great job. Your answer is correct. Okay, so here, again, I had not simply coded this. Y'all coded this in groups. So here on this particular problem, what I want to point out to you is something we haven't seen, even though we've covered random. And that is the fact that you can make in Python what is called a seed. So check this out, random.seed, and then I can put anything in here. Let's just say I type in, I'm gonna type in David Thompson with a space. Doesn't matter if I put a space, but I just want you to see I can put anything in there. So what does that do? Well, let me just run the program once. Look at these quote unquote random numbers. 3 minus 2, it's 1. I run it again. The same exact two numbers, 3 minus 2. I run it again. I get the same random numbers, 3 minus 2. Every time I run it, it's going to generate 3 and 2, even though the numbers are supposedly random. So when I get rid of that seed, I comment that line out. Now I get 8 minus 1. I run it again. I get 6 minus 4. I run it again. I get 6 minus 2. The random numbers change. But when I put that random.seed there, I always get 3 minus 2. Now, of course, I can change my seed to something else. Let's say I change my seed to Colson, and I run this. Now my random numbers are always, the first two numbers are generated are always 4 and 2. Again, 4 and 2. Again, 4 and 2. So what we explain to students is that there's no such thing as random numbers in programming. It's what we really call this is pseudo-random. So here, there's no such thing as true random numbers in programming. It's really pseudo-random numbers. Because what is a random number? What we see as a random number in programming? Well, it's really under the hood or behind the scenes, whatever phrase you like to use, is that there's really an algorithm that's at play. There's really an algorithm. If you say, hey Python, give me a random number between 1 and 100. Well, Python is really following some algorithm, some recipe, cooking it up in a pot. This is a predefined recipe where they perform a variety of mathematical operations on a given number. And when they're done performing that very sequential series of mathematical operations, they then spit out a number for you. So we view it as being random, but in fact, that number is not random, and we can prove it, or it's not a true random, we can prove it by giving it a seed. So what they call it a seed? Why? It's almost like you can put a seed in the ground from which you grow a tree, right? Well, think of this seed as we are putting this seed into the random number generator. And then that random number generator in Python, it's able to grow our tree of random numbers from the seed that we give it. Does that make sense? We're able to grow these random numbers from Python's random number generator. We're able to grow it from the seed that we give it. And so when I give it the seed of Colson, every time the first two numbers it grows are 4 and 2. If I give it, you can give it a string as a seed. You can also give it just a number as a seed. I give it the number 420. So I can give it the number as a seed. And every time I give it the number 420, 6 and 1 will be the first two integers that it grows from the random number, from the random generator seed. So I share that with you because you do need on this particular program to use a random number generator. And so you'll notice every time I run this program, the first two numbers were 9 and 2, followed by 10 and 7, followed by 1 and 6. So come up to the addition. 9 and 2. Why does it say 7 and 1? Maybe I ran it weird. Let me see. 9 and 2, 7 and 1, 6 and 5. Let's see. That's not the good example. 9 and 2. Well, this is weird. Maybe I didn't use the seed here. Maybe I ran this before using the seed. That doesn't make sense. Or you know what? Sorry, maybe I had a difference. Let me see. Now this is confusing to me. 927165. 927165. Yeah. That's strange. There's got to be some explanation. All I can assume is that maybe, wow, I'm surprised I didn't catch this before. Maybe when I made this is I perhaps changed my seed in the middle of running some of these, because if you can see that several of them are the same. Like if you look here at this multiplication, 9, 2, 10, 7, 1, 6, 9, then here we run it again, right? You can see the red, I run it again. 9, 2, 10, 7, 1, 6. I run it again, 9, 2, 10, 7, 1, 6. Even when I do the division, here I wanted to point this out to you. Even the division, 9, 2, 10, 7, and 1, 6. So it's still those exact same two numbers. 9 and 2 were what were generated. But in order to do the division, what I did in the background is you first multiply 9 and 2 together. Because if I want to ask a division question and I want it to divide cleanly, I can't random. So the two numbers that were generated were 9 and 2. I'm not going to ask the user what is 9 divided by 2. That's not what we're trying to get at, right? We don't want them to be able to do some crazy real number based division and answer 4.5, or what is 10 divided by 7. We don't want to ask them 10 divided by 7. So 10 and 7 were the two numbers generated. So on this division one is we first multiplied those two numbers together in the code. And then that answer, which is 70, we asked the user, give us the result of, or answer the question, which is take that answer 70, divide it by the first number that was generated. And we asked the user to give their answer. And so the user enters 7, and we compare their answer to the second number generated. I'm only saying that once, but I think that's maybe clear if you followed. So this is a significant program. I would guess it would take you all anywhere from 3 hours on the low end to maybe 6, 7 hours for those who were interested in seeing. This is program 2 that I give, that I actually gave this semester to our college students, for anyone who is interested. Any questions on this before I move on? Anyone? Opportunity, questions? Cool. I am moving on then. So I'm going to close this. I would encourage you, make your new file new, save this as in module 5, make a new module folder, module 5, and call this module 5 notes. And here we are. So we're finally going to look at loops. So what if we wanted to ask you, hey, I want you to print programming is fun 100 times. And I asked you to do that. Would you really want to type programming is fun 100 times? Okay, and a lot of you know loops. Now that I see that we've really pruned down the size of the students, the ones who are really here are the ones who are really keeping up. And so many of you already studied loops, but bear with me because not everyone has. Would you really want to type programming is fun 100 times? That would be crazy. I mean, you could come here to Thani, and I mean, there would be some type of efficient ways to make it happen. Programming is fun, and I already misspelled that. And then, so that's done once. I could copy this, 2, 3, 4, 5. Okay, I can copy that 5, 10, 15, 20. So there's 20 times. And I could copy all of that 25 more times, or 4 more times, 40, 60, 80, 100. There, I've printed it 100 times. Very, very exciting. Okay, sarcasm intended. So there's got to be a better way if you needed to print something over and over and over. And in fact, there's 2 ways. I'm going to show you just very quickly. I'm going to jump way ahead because we're not going to cover this until even next time. But we have what's called a for loop. For I in range 100. That's just going to print whatever's inside it 100 times. Done. Pretty straightforward. And we're going to cover more about the for loop next week. We also have a while loop. While, I can come up here and make a value I. How about say count? Count equals 0. While count is less than 100. Print programming is fun, and then let's increment count. So now count will change to 1. Is 1 less than 100? And again, I'm not expecting you to follow this fully. I'm just showing you these are 2 of the type of loops that we're going to cover this week. And let me actually print the count here. So actually, I'll start count at 1 since we're trying to make this easy to understand. I'm going to print here formatted printing. Here, let's do this. Dot format count. So if I printed this, here we can see we print the count number, programming is fun afterwards. I'm not giving the explanation of all of that right now. I'm just showing you this is a trailer of what is to come, if you will, that we can actually use looping constructs to do repeated actions over and over. So Python gives us this looping construct where I started a count variable. I then have this while loop, okay? And we're going to explain this in full detail. Okay, this is just, again, the trailer, where I have this while loop. And notice what is inside that loop, these two, the print statement and then the statement count equals count plus 1. That's both inside the while loop. Someone unmute, please, and tell me, how do we know it's inside the while loop?
The tab.
Yeah, the indentation. As we mentioned, other languages, that's not how something's inside the while loop. I mean, you might think it is based off of the tab, but it could be tabbed incorrectly. So, but in Python, that is strictly how we know that something is inside a while loop or an if statement, that it is indented, it is tabbed over, and I'll call it a tab. It's really the 4 spaces. Make sure we do know that, the 4 spaces for Python purposes. So those 2 statements are inside that while loop, and that while loop just simply keeps a count, okay? And we check the count. Is it less than 100? It is. Enter the loop, do what is inside the loop, and then continue the process. And again, we'll study in a small example in detail. So Python gives us 2 loops. We have while loops and we have for loops. For those who have studied Java or other languages, it's going to be interesting for you to learn that Python does not have a do while loop, which is, I actually have never looked up why. I'm sure there is a logical reason of why they don't have a do while loop, a rational reason. I can't think of one because I think a do while loop is quite valuable. And there's ways around that. I just do what the students know me famously for, my while true loops, which is what I think are some of the easiest loops just to code up. Put your while true and worry about the stuff afterwards. That effectively takes the place of a do while for those who have studied do while, but Python does not have that. So let's look at the syntax. I'd rather actually just jump in before even the syntax. Let me even just go over and show you this problem in detail, this one that I just showed you. So here, let me make this small. I'm going to make count less than or equal to 5. I want to zoom in some. And again, here's where we can get a lot of value from seeing the count and from seeing the debugger. So I want to debug this very briefly, and I want you to watch very carefully what you can see happen. So debug current script. Cool, I actually have 2 different ones. Interesting. So count starts at 1, okay? So we save 1 into count. So here, look at the right side of the screen, count is 1. Right now, since count is 1, is count less than 5? Is 1 less than 5? Yes, it is. So that's what that while statement is saying. It's saying while the following statement that comes after the word while it is true. So right here, I want to be very clear that this statement that comes after the while right here, that has to be a Boolean expression, okay? So that statement that comes after the while, it should be a Boolean expression. So while that Boolean expression is true, we then execute the code inside the while statement. Okay, so while count less than or equal to 5. Well, what is count? Count is 1. Is 1 less than or equal to 5? That's a Boolean expression, and it is true. It evaluates to true. So that is a true statement. So we enter the while loop and we print. Print, programming is fun, and we use formatted printing, so we put the 1 there, and we print 1 colon space, programming is fun. Then we increment our count. So count was 1, but now we're adding 1 to it. So now count is 2. Okay, count is 2, as you see over here. I don't know why this got messed up here, but that box should be up above. Count less than 5 is 2 less than 5. That is true. Okay, so now we look at this. We print count using formatted printing. Programming is fun. Now count plus equals 1. Count becomes 3. Okay, you look over here at the side. Count is now 3. Is 3 less than or equal to 5? The answer is true. So we enter our while loop, and we once again print this statement using formatted printing. So we're going to print 3 colon, programming is fun. We increment our count. Count is now 4. Is 4 less than 5? That's true. So we again print our statement, 4 colon space, programming is fun. We increment our count again. Count becomes 5 over here on the right. Is 5 less than or equal to 5? Yes, that's true. So we again enter the while loop. We execute these 2 commands, these 2 statements on lines 3 and 4. We print 5 colon, programming is fun. We increment count, so count is now going to be equal to 6. Look over here on the right at the variables. And Thani, count is 6. Is 6 less than or equal to 5? That is now false. Because that is false, we do not enter the while loop, and code will continue, execution of your program will continue after the while loop. So a better example, I'm not going to go run through this again, but a better example would have been if I had put a line of code here on 5, like if I had print hello, execution will go to line 5, which is after the while loop, and your program will keep running after the while loop. But because that Boolean expression was now false, the while loop exited, and it does not execute the while loop anymore. So this is, if y'all can give me a thumbs up in the participant window, please, if that makes very clear sense to all of you. Okay, and I'll tell you what's really cool. Now that we're going to get into while loops and for loops, this is finally where we can do some meaningful, we can solve some meaningful problems. Because before you talk about loops and learn loops, every program is simply, it's a one-off. Meaning you run it, it stops after, a fraction of a second, and it's a one-off. But now that you have loops and we can learn about loops, we have a lot of interaction that we can do with our program. We can run a menu and we can interact with that menu. And then that menu, we can go to different levels within this menu and back out. We can keep, you can run and interact with the program for a long period of time. I'll show you very quickly, just to motivate this concept even further, I had open recent files. Where was it? Right here, I think. So this was a program, this is program 4 that I gave the students this semester. I want to run this and just show it to you briefly, because I think this is it's a fun one, which is using menus, it's using loops, it's using functions, and even lists, I believe. So here, just a menu, we show it to the user. And let's just say we ask the user, they have these 7 choices. Of course, they can hit 7 and exit right off the bat. But what if I run it again? Are you smarter than a 3rd grader? And so let's just say they want to do this first option, which was math practice. So this is kind of like this problem for program 2. Let's practice some math questions: addition, subtraction, multiplication, or division. So let's say I want to practice multiplication. So we ask 5 questions. So 11 times 6. I'll put some wrong answers in here. I'll put 10 here. I'll put 45 here, and I'll put 50 here. Okay, so you got 3 out of 5 correct. You can now practice some more, or you can return to the main menu. So now I can return to, I'm in a loop. See, I presented that menu once. Let's say I'll do addition this time. 4 plus 8, 12, 9 plus 5, I'll put some wrong numbers, 14 and 16. You got 3 out of 5 correct. You can practice more or return to the main menu. So it's in a loop. It brought me back here, right? It didn't just end the program. So let's say I go back to the main menu. So I choose option 5. At option 5, notice now it brought me back to the main menu, which was in a loop on its own, okay? So there's a lot of thought involved of how you actually build a program to solve what you're seeing. What about this race to the finish, multiplication? So here, you have 10 seconds to answer as many subtraction questions as possible. Both the questions and the timer will start once you type anything or once you hit enter. So if I hit enter, I have 10 seconds, and this is not a good keyboard. I'm on my laptop, so I'm not going to do this very fast. 1, 6, 10, 2, 5, 7, 1, 1, 4. So I was able to get 8 questions answered correct in 10 seconds. That's my best, and I could keep playing this. Finally, there was this guess the number problem here. So I guess a number between 1 and 100. How quickly can I do it? Your time starts once you hit enter. So enter a guess between 1 and 150. The computer had randomly generated a guess. It says my guess is too low, so I choose 75. Your guess is too high, so I'll choose between 50 and 75. Let's say 62. Wow, I got very lucky. And 62 was the actual number that the computer had generated. So this was a program that was using loops. I just wanted you to see a program that constantly, where you're, as the user, interacting with the computer, and it's constantly re-showing you, for example, a menu. That's the easiest example to have menu-based programs. So you can see that as soon as you interact with the menu and you finish a certain task, it brings you back to that menu, and it shows you the menu again, and you can interact with it again. I'll go ahead and hit exit, and it prints me at the end of this particular program, printed some information, some statistics that I had kept for the user. So once you learn about looping, it's a whole new world of problems and interaction with the computer opens up to you. So it really makes it a lot of fun. So while loops, getting to this, we have 2 minutes left in this particular session before I start the next session. So just very quickly, we covered that one example in detail just now with that while loop here, where we printed programming is fun 5 times, okay? So what really happens in a while loop is we have this loop continuation condition, which I told you is a Boolean expression. It's going to evaluate to true or false. If it evaluates to true, we enter the loop, we execute the statements within that loop, right here. We execute these statements within the loop, and then after we execute those statements, we go back up and we evaluate the loop continuation condition again. And if that loop continuation condition again is true, we again enter the loop, we again evaluate those statements inside the loop, and then we go back up to the top, the while, the loop continuation condition, and this repetitive, iterative process continues again and again of testing the loop continuation condition. If it's true, enter the loop, execute the statements in the loop, and then come back up and test the loop continuation condition once more. When do we finally exit the loop? If that loop continuation condition is false, if it evaluates to false, we do not enter the loop, and we simply exit the loop, and we continue, the program continues after the loop, okay? I'm gonna go ahead and stop this session, and I'll make the link for the new session within Slack.